Now we're looking on the other side of the paper. The first side says Oak Harbor High School Science Problem Solving Rubric. And we're looking on the other side at Practice Problem 1. And we're going to step through this and look at how we apply the 5-point UDRSS UDRS point scoring rubric to this problem. That's what we're looking at. So I'm going to start here by writing on the left side U, D for data, R for relationship, S for substitution, and S for the final solution. And then we'll go back through when we get this problem done and see how many points we have earned and what we earned those points for. So we're going to start off by looking at what we know. We know in this problem that your chemistry teacher empties a dehumidifier once a day. The capacity of the tank is 3,780 milliliters. And so I'm out of the air in my shed. I am pulling 3,780 milliliters of water every day, each day. So that's one thing we know, 3,780 milliliters per day. That's what I'm pulling out of the shed. The thing we are looking for, we'll call that the unknown, the piece of data that we're looking for. And the thing we're looking for here in this problem is, what is the number of molecules of water the dehumidifier collects in 1 millisecond? That's what we're looking for. We're looking for molecules of water per millisecond. Every thousandth of a second, how many molecules are we pulling out of the air in my shed? And we have all of these relationships listed here, and we're going to make use of these relationships as we go through the problem. So let's now put down our relationships that we have. We're going to start this problem with, I just know it's going to take me some space over here. I'm going to move these and write them down later so that I can start clear over here on this side of the paper. Oops, there we go. So I know that we are starting with 3,780 milliliters of water per day. That's per 1 day. And what are some of the other relationships I can do? Well, first of all, I'm going to change this unit up here that's milliliters. I'm going to change this unit. I want eventually to get something called moles on the top. Well, so I'm going to have to use some of these relationships, and right now you're going to look at these and go, well, how did he know which relationships to use? You're going to just have to play with these relationships until you find a way to make milliliters go away and moles show up. Well, I see here that I could make milliliters go away by putting this relationship in. So I'm going to put in milliliters of water. on the bottom. And in that particular case, if I have milliliters on the bottom, I'm going to have to put grams on the top. So when I say that will make my units change, remember what I'm really talking about here is that this unit and this unit factor out. They factor to 1, and we let them go away. We ignore them because they've become 1. It's the same thing on the top as you have on the bottom. So the next relationship I'm going to be choosing is to make this grams right here go away. How am I going to make that grams go away? Well, let's see. Do I have grams of water up here anywhere? I've already used this relationship. Where's my pointer? There we go. I've used this relationship. So I'm going to choose this time to use this relationship. So I'm going to put grams of water on the bottom so that those will now factor out. And the other unit in this relationship is something called moles of water. Then we're going to have another relationship we're going to use. We're going to get moles of water to go away. So other than this spot here that we've already used them, where do we see moles of water? Oh, here's a place we see moles and number of molecules. Okay, so that's our next relationship we're going to use. Is we're going to have moles of water on the bottom, moles of H2O, and on the top we're going to have, let's see, I'm looking at this relationship, so on the top is going to be molecules. So we're just moving over, and it turns out I'm going to run out of room on this line and just kind of have to continue on to the next line here in just a moment. But right now this unit has canceled this one, and we can go on to the next step and we can make molecules. This is the molecules we used before. Molecules is where we want to be, isn't it? So at the moment, that's what we want. We want molecules to be the unit on the top. Good. This is a great place now for me just to move down a line, down just a little bit here, and go back to the left. And we're just going to continue this problem. We have molecules on the top, and that's what we want. Now we're going to change our focus to the unit that's on the bottom. The unit here is day. I'm going to get back up to see the top of our problem. I want the unit day to go away. So that means since the unit of day here is on the bottom, I need to put a unit of day here on the top so that this one from the bottom and this one from the top will cancel. Now, do I have any unit up here with day? Yeah, I'm going to be just working with time right now to get time changed from days to eventually milliseconds. I think you see where we're headed. So days, and hours. We can switch days to hours. And our time unit that we're looking for is always going to be here on the bottom because the time we started with is on the bottom. So now I have hours on the bottom from right here, and I want hours to cancel out, so I'm going to put hours on the top like this. Now those hours will factor out, and we're going to change hours to minutes. So my new unit here on the bottom is going to be minutes. My next relationship, I'm going to convert minutes probably to seconds. And that's supposed to be a 1 there. I just noticed that. So we want minutes here on the bottom to be canceled by a minute on the top. One on the bottom, one on the top, so that they cancel. And our new unit here is going to become seconds. And we're here at our last relationship, because you see when we get seconds canceled in this next relationship, seconds are going to cancel, and what unit is left on the bottom? Well, our relationship here is going to be between seconds and milliseconds. So what have we just done? Some of you followed that. Some of you are going, I'm lost. Well, if you're lost, you're going to have to go back and look at this again a few times and write